have two systems, G1 and G2. One is stable and one is unstable. So the question is, how do we know the open loop stability of these systems? And in this video, we are going to go through 5 methods we can do that. And the first method is using the fall function. So with the fall function, you'll be able to see the open loop pulse of any system. So if I want to see the open loop pulse of G1, I just have to put fall into G1, and you can see it shows me the open loop pulse. So all of them are on the negative side of the S-plane, so it is stable. If I check for G2, you will see one is on the negative side of the S-plane, while the other two are complex conjugate force on the positive side. So this system is unstable. The second method is using the impulse function. So impulse is just applying an impulse to the system that is perturbing the system. As we know, a system is stable when it has the capability of returning to its equilibrium position after it is perturbed. So I expect a stable system to return to 0 if I give it an impulse after some period of time. It is initially at 0, and I expect it to blow to infinity after applying impulse if it is unstable. So let us use the impulse function. So impulse G1, as you can see, I have my systems here. So for G1, after applying an impulse, it starts at 0, goes up to almost 0.12, and then returns to 0, which is the initial position. So this system is stable. But if I check for the other system, so as you can see, it starts at 0 and then goes to infinity. So 8 times 10 to the power 28. So this system is unstable. So the third method you can use is using the step function. So what step is? It is applying a step of 1 to the system, which is a bounded input. So for stable system, we expect the output to be bounded if the input is bounded, and we expect the output to be unbounded. So applying a step to G1, as you can see, it settles at 0.5, which means it is a bounded output giving a bounded input. So this system is stable. But if I apply step 2, G2, as you can see, it blows off. So this system is unstable. So that is the third method. The fourth method is using the calculating the eigenvalue of the system. So you can calculate the eigenvalue, but in this case you have to transfer your system from transfer function model to state space model. So how can you do that in MATLAB? So for example, I know my G1 is 2. So now I need to find my A, B, C, D matrices. So you use this command, transfer function to state space, and then you just put the numerator of the model, which is 1, and the denominator polynomials, you have 1, 7, 6, and then 2. So this will give you your matrices A, B, C, D. So you have your A, B, C, D matrices. So now we have our state space model. So if you want to find the eigenvalues of the system, you just put each A, you use the A matrix, and you can see they are actually the force of the system, and you'll be able to know the stability of the system. So the last method is using the classical control tools. You can use root locus, body, plot, Nyquist to check the open loop stability and have an idea on the closed loop stability of your system. So you can use al locus, that is for root locus, body function or margin for body plot, and you can use NIQs. So let us use an example with root locus. So if you just have root locus G1, so this will give you the root locus plot. So you just have to check the initial position of your faults. So as you can see, all my faults initially are at the negative side of the S-plane, which means it is open loop stable. If you want to learn how to find Laplace and inverse Laplace transform in MATLAB, watch the video on the screen.